So machines have to make smart decisions, but they have to do it in a world that's, well, messy and uncertain. Today, we're going to explore the language they use to handle that uncertainty, probability. It's the very foundation of how they reason. I mean, think about it. A machine learning model almost never has all the facts. It's working with noisy, incomplete data. So it has to make predictions, which are really just smart bets. The question is, how does it actually do that? Because let's face it, uncertainty is the default setting for the real world. Our data is always going to be a little bit noisy, a little bit incomplete. A model can't just ignore this reality. It needs a formal way to talk about it and manage it. And that formal language is probability. So by the end of this quick explainer, you'll get it. You'll understand the core language that allows a machine to go from a state of, I have no idea, to, okay, I'm about 85% sure. All right, let's build up our intuition here, and let's forget about all the heavy math for a minute. We can actually get our heads around the most important ideas just by thinking about something super simple, flipping a coin 2 times. Okay, so the first building block we need is something called the sample space. Now that might sound a little bit formal, but it's a really simple idea. It's just a complete list of every single thing that could possibly happen. For our 2 coin flips, what could happen? Well, you could get heads, then heads, or heads, then tails. You could get tails, then heads, or you could get tails, then tails. That's it. There are exactly 4 possible outcomes. This list is our entire universe for this problem. Now, once we have that whole universe of possibilities, we can talk about an event. An event is just a way of zeroing in on a specific outcome, or maybe a group of outcomes that we actually care about. For instance, what if the event we're interested in, we'll call it event A, is the first toss comes up heads? We just look back at our list of all possibilities. Which ones match that description? Well, only 2 of them, right? Heads heads and heads tails. That little group of 2, that's our event. And this leads us right to the heart of probability. The probability of an event, written as P of A, is just the number of outcomes in our event divided by the total number of outcomes possible. So for us, that's 2 divided by 4, which is 0.5, or a 50% chance. It's just a number that measures how likely that event is. Okay, but here's where it gets really powerful for machine learning. Because in the real world, we rarely care about just one thing in isolation. What we really need to know is how different events relate to each other. And this brings up 2 key ideas. First, there's joint probability, which is just the chance of 2 events happening together. But the real game changer is conditional probability. This asks a much more interesting question. If I already know that one thing has happened, how does that change the probability of this other thing happening? And that idea right there is the absolute essence of learning. It's not about a static, one-time calculation. It's a dynamic process. When a model gets new evidence, it uses conditional probability to update its beliefs about the world. Here's the formal rule that makes it all work. The probability of A, given B, is calculated by taking the probability of A and B happening together and dividing that by the probability of B happening at all. This one simple equation is the engine for reasoning under uncertainty. And this is absolutely crucial. Every single time a model trains on a new piece of data, it's essentially just solving a version of this equation over and over again, updating its internal parameters based on the new evidence it just saw. Okay, enough theory, let's make this concrete. How does this actually show up in a system you probably use every single day? A perfect example is your email spam filter. It's a classic problem where a model has to look at an email and make a decision. Is this spam or is it not? Here's basically how it thinks. It starts with a general belief, called a prior. For example, maybe 10% of all emails are spam. Then it sees new evidence, like the email contains the word winner. The filter knows from past data how often winner shows up in spam. So it combines those 2 pieces of information and it updates its belief. The probability of this email being spam, given that it contains the word winner, is now much, much higher. This whole update process is formalized by Bayes' rule. It's just a really clever way of rearranging the math. It lets us calculate the thing we want to know, the probability of spam given the evidence, by using pieces of information that are much easier for us to count and measure. And this idea comes from Reverend Thomas Bayes way back in the 1700s. It's kind of incredible that a concept this old is still the core engine driving so many of our modern AI systems. So to bring it all together, probability is much more than just coin flips. It's the formal framework, the rule book,
that allows a machine to reason logically when it doesn't have all the answers. If you remember just one thing, let it be this. Probability is the engine that allows systems to learn by systematically updating what they believe to be true every time they see something new. And that leaves us with a final thought to chew on. When you get right down to it, how much of what we call intelligence is really just being very, very good at doing this one thing, constantly updating our model of the world based on new evidence?